Hello and welcome to the second video of our Year 9 Indices series. Today we'll be discussing specifically what a negative index is. So let's dive straight into it. What do negative indices actually mean? We should be aware of what 5 squared, 2 to the 4, and all what these positive indices are, right? 5 squared, if we were to simplify and dumb it down a bit, is literally just the same as saying 5 times 5. So we're just multiplying 5 as many times as our index tells us to. Same thing with the 2 to the power 4, right? 2 to the power 4 is just 2 times 2 times 2 times 2. Why is it 4 times? Well, because our index told us to. Now, what about 5 times negative, 5 to the power of negative 2 or 2 to the power of negative 4? What does that mean? By the same logic, can we multiply something a negative number of times? Not really. But what we can do is we can actually divide. But first, let's try and evaluate what these two numbers are using our calculator. So if you were to put 5 to the power of negative 2 into your calculator, you're going to end up getting 0.04. Now, whilst that's useful of sorts, I think a better way of representing it is 1 over 25. And even better than that would be saying 1 over 5 squared, because 5 squared is 25, right? Now, what about 2 to the power of negative 4? Well, 2 to the power of negative 4 is equal to 0.0625 on a calculator. But an even better way of representing that, if we just use our SD button, that's going to equal 1 over 16. And even better than that, 1 over 2 to the power 4, because 16 is 2 to the power 4. Now, hopefully you can see the pattern here. 5 to the power of negative 2 is just 1 over 5 to the power of positive 2. 2 to the power of negative 4 is just 1 over 2 to the power of 4. And so this is where the idea of multiplying negatively is actually just the same as dividing. I wanted to also go through one more example here. Let's say we have 5 to the power of 3, 5 to the power of 2, 5 to the power of 1, 5 to the power of 0. We know that anything to the power of 0 is equal to 1. 5 to the power of negative 1, and 5 to the power of negative 2. So let's just do this for our little mini exercise over here. So let's just start off with what is 5 to the power of 3. You should all be aware of what 5 to the power of 3 is, hopefully. It's equal to 125. Now, 5 squared is even easier. That's 25. Now, what happened? What happened to go from 125 to 25? We had to divide by 5. Now, what's 5 to the power of 1? It's 5. What's 5 to the power of 0? It's 1. So what happened to 25 to 5? We had to divide by 5. What happened from 5 to 1? We had to divide by 5. So it makes sense that to go from 5 to the power of 0 to 5 to the power of negative 1, we have to divide by 5. And now what is 1 divided by 5? It's 1/5. Now, to go from 5 to the power of negative 1 to 5 to the power of negative 2, what do we have to do here? We have to divide by 5 again. And 1 over 5 divided by 5 is 1 over 25. So you can see how that is the real way of how we get negative indices in the first place. Now, how can we generalize that into an actual formula? This here is what the general definition of a negative power is. We can say that a to the power of negative n, so a and n are just both numbers. A to the power of negative n is 1 over a to the power of n. And hopefully we sort of got that from the previous slide. And we can see that a to the power of negative n is simply the reciprocal of a to the power of n. Remember, what is the reciprocal of something? The reciprocal of a is 1 over a. So reciprocal just means 1 divided by what the original number was. So for example, the reciprocal of 2/3 is going to be 1 over 2/3. And we know that we can actually simplify this and multiply the top and bottom by 3 to make this look prettier. So we're going to get 3 on the top. 2/3 times 3 is just 2. So you can see the reciprocal of 2/3 is just 3 on 2. Basically, we've just flipped the fraction around. So let's move on to some actual fractions and negative indices. So given that we have a to the power of negative n is the reciprocal of a to the power of n, how would you simplify 3 to the power of 4 to the power of negative 1? Well, we can write it as 1 over 3 to the power of 4 to the power of positive 1, right? That is the definition of what a negative indice is. So now we can simplify this. So 1 over 3 to the power of 4, we can multiply the top and bottom by 4. And the reason for that is so we can cancel out this fraction on the bottom. So on the top, we get 4, and on the bottom, we get 3. So our answer is 4 over 3. Now, how do we extend that definition to a over b to the power of negative n? Well, a over b to the power of negative n is just 1 over a over b to the power of positive n. And we know from our previous video that a over b to the power of n is the same as a to the n over b to the n. Now, let's simplify this, right? To simplify this, we need to multiply the top and the bottom by b to the n. Why have I chosen b to the n? Because that's going to result in cancellation happening here. So here we're going to get b to the n on top, because 1 times b to the n is b to the n, over a to the n. And so that is what a over b to the power of negative n is equal to. Now, is that a formula you need to memorize? Of course not. It's more so to do with the process. So a over b to the power of negative n is 1 over a over b to the n, and then just keep going with the steps, and eventually you'll get the answer. So this is something that we don't need to memorize. Now let's move on to some easy examples. So with question 1, question 2, question 3, and question 4, I want you to pause the video and have a go at them on your own time, and then unpause so that we can go through the solution. All right, so let's go through question 1. First, we want to express the following with positive indices. So 2 to the power of negative 3 is equal to 1 over 2 to the power of positive 3. Now, I could technically say it's equal to 1 over 8 because 2 to the power of 3 is 8, but I think we want to leave the answer as this just because the question asked for positive indices. So we want to keep the index there. Now let's move on to question 2. 7 to the power of negative 2. So that's simply equal to 1 over 7 to the power of 2. And now once again, I can just say it's equal to 1 over 49, but I think I'll leave it like this just because they want a positive index. Now let's have a go at question 3. Now with question 3, this one's a bit trickier. So we have 3 over 5 to the power of negative 2. So one way of doing this would be just saying 1 over 3 over 5 to the power of positive 2. Now, there's nothing wrong with this, but it does look a bit messy. What's a better way of doing this? The better way is by actually just splitting this up. We know that negative 2 is the same as just negative 1 times 2, right? Now, why have I done this? Because what's 3 over 5 to the power of negative 1? Remember, powering something to a negative 1, we basically are just reciprocaling it. We're flipping it over. So that's just equal to 5 over 3. And so now we're left with 5 over 3 squared. And which one looks prettier? Clearly this one, right? So that's why 5 over 3 squared is probably the better looking answer, even though they are both technically correct. Now let's have a go at question 4. So with question 4, we have 3 1/3 to the power of negative 2. The first thing I would do is change this mixed numeral into an improper fraction, and that's going to make life much easier for us. Now, if you don't know how to change mixed numerals into improper fraction, there's a quick way of doing it. You always keep the same denominator, and to find the numerator, you multiply these numbers, and then you add on this number. So 3 times 3 is 9. You plus on 1, so that gives us 10. So 10 over 3 is the same as 3 1/3. So let's write 10 over 3. So we have 10 over 3 to the power of negative 2. Now what happens? Well, it's very similar to the question 3 over here, right? We can either say that's the same as 1 over 10 over 3 squared, or we can split it up into negative 1 to the power of 2. So for that one, we're just going to say it's equal to 3 over 10 to the power of 2. And if that doesn't make sense how I got this answer, just look at the solution for question 3 again. It's literally the exact same thing. So now let's go on to some even more examples. Express the following as a number or fraction with negative indices. So I'll get you to pause the video and have a go at these 4 questions. And so unpause so that we can go through the solutions. So let's go through question 1 now. 1 over 169. We know that 169 is the same as 13 squared. So that would be our first step, 13 squared. Now, where to from here? Well, we're trying to reverse engineer stuff, right? We're trying to bring in a negative index. So essentially what's happening here is we know that 1 over 13 squared is the same as 13 to the power of negative 2. And that is going to be an answer for question 1. Let's move on to question 2. With question 2, there's actually quite a few ways which we can do this. And that's a flaw of the question. But let's go through both ways. So we have 1 over 64. We can write that as either 1 over 4 cubed, or we can write it as 1 over 8 squared. Now, 1 over 4 cubed, we know is the same as 4 to the power of negative 3. And 1 over 8 squared is the same as 8 to the power of negative 2. So both of these answers are going to be acceptable. So with question 3, we have 4 over 9. Now, how do we go about doing this? Well, 4 over 9 is the same as 2 squared, because that's 4, over 3 squared. Now, we can write that as 2 over 3 all squared. Now, the problem is the question wants us to have a negative index, and right now we have a positive index. So what's the trick with this? Remember, you flip the fraction and you make the index negative. So that means we can say it's 3 over 2 to the power of negative 2. Now, these two are the exact same. Remember, because 2 over 3 is the same as 3 over 2 to the power of negative 1. And that's why this question works. Let's move on to question 4. With question 4, we have 64 over 27. We know that 64 can be written as 4 cubed, and we know that 27 can be written as 3 cubed. And so 4 cubed over 3 cubed, we know simplifies to 4 over 3 all cubed. And once again, just like example 3, we can, because we want to introduce a negative index, we basically flip the fraction and force the index in. So that's going to be 3 over 4 becomes negative 3. And that is our final answer. Let's move on to some more easy examples. So here we have 2a to the power of 4, b to negative 3, all to the power of 2 over 9 divided by 3a to negative 2 over b. Now, how on earth do we do this? Well, once again, I want to start by doing keep, change, flip, because I've got a fraction divided by another fraction. So let's keep the first fraction the same. Change that division to a multiply sign, and then let's flip our other fraction. Now that we've got this, let's start introducing our index laws. So this squared is applying to everything inside of our index. So we can say it's 2 squared, which is 4. We have a to the power of 4 squared, which is a to the power of 8. We have b to negative 3 squared, which is b to the power of negative 6, all over 9, times b over 3 times a to the negative 2. Now, where do we go from here? Well, we know that b to negative 6 is the same as 1 over b to the 6. So really, this b to the negative 6 doesn't belong here. It should actually be b to the 6 here. And we can erase this guy over here. What else can we do? Well, we have a 1 over a to negative 2 over here. Now we know that a to negative 2 is actually 1 over a squared. And so that's the same as a squared over 1, because remember, we can multiply this by a squared, multiply this by a squared. This becomes 1, this becomes a squared. So really, this guy can go over here. So now we can simplify everything. 4 over 9, a to the power of 8 times a squared. So that's going to be 4 times b times a to the power of 10 over 9 b to the power of 6. 9 times 3 is actually going to give us 27. So we're going to get 27 over here. And now we can simplify a bit more by cancelling out one of the b's. So this b disappears. This becomes to the power of 5. So our final answer is 4a to the power of 10 over 27b to the 5. Now let's move on to a harder example. So the question is solve for z. I'll get you to pause the video and have a go at this, and then we'll go through the solution. Okay, so hopefully you've had a good long think about this question. So here we have 1 over z to the power of n over 2 is equal to 3 to the negative 2n. How do we go about doing this question? Well, the first step would probably be by squaring both sides. Now, why is that a good idea? The reason we want to square both sides is because we want to get rid of this fraction, because we don't know what fractional indices are yet. We will in the next video, but for now we don't. So what we're going to do is we're going to say 1 over z to the power of n over 2. We're going to square that. And that means we're also going to be squaring the other side. So we're going to be squaring this. Now, when we square, remember, we're just multiplying the indices. So we have 1 over z to the power of n, because n over 2 times 2 is n, is equal to 3 to the power of negative 4n. Now here, all we want to do is actually put the index laws into action. 1 over z to the power of n is just 1 to the power of n over z to the power of n. And 1 to the power of n is just 1. So it's just 1 over z to the power of n. Here we have 3 to the power of negative 4n. That's the same as 3 to the power of negative 4 to the power of n. And we know 3 to the power of negative 4 is 1 over 3 to the 4, which is 1 over 81. And then if we're powering that to the n, we're going to get 1 over 81 to the n. So we can see now that we have 1 over z to the n is equal to 1 over 81 to the power of n. Now, if z to the n is equal to 81 to the power of n, well, clearly z is equal to 81. Now, this question is quite difficult in that there's a lot of just weird algebra all over the place. But hopefully you can see that no matter which order you can do this question in, like there's multiple ways of doing it. At the end of the day, as long as you use the index laws properly, you will get the answer. So that brings this second video of our indices index series to a close. In our next video, we'll be talking about what fractional indices are, so stuff like cube roots and square roots. So hope to see you in the next one.